Okay, so we're going to start talking about zeros of polynomial functions. That does not sound like something we haven't talked about before, because we have. Okay? We found the zeros in a variety of ways. We found zeros by factoring. We found zeros by graphing and using synthetic and long division. All right, but today we're going to have to find some of the zeros by quadratic formula. And some of them are going to be irrational and some of them are going to be complex or imaginary. So we are going to have some we talked about this, expiration next Friday, all of chapter 1. This Friday's quiz, anybody need to take a picture of that? Otherwise it's on the board. What's on this Friday's quiz? We good? I'll give the review out Wednesday so you'll know. We're good? Okay. Today's learning targets. I can generate a list, okay, of all the possible rational zeros for a polynomial function. It'll be a long list of numbers. That I can find them by graphing and dividing. I can also find complex zeros. When you get to the end, you will need to, after you've done the dividing from this learning target, you may need to use quadratic. I can rewrite a polynomial in factored form with either prime factors or all linear terms. That's at the end of the lesson today. And then I can give the zeros and generate the polynomial in either standard or factored form. We're just going to do factored form. Okay, this is given the zeros, sorry. All right, before I go any further, I want to do a warm-up today. I think I have a slide that would help. Right here. If you had, don't even look at that yet. If you had you knew the zeros were -3 and 5, can anybody tell me what the factors would look like? X plus 3 and x minus 5, good job, okay? Then if you FOILed that together, it would become x squared plus 3x and a minus 5x. Everybody okay if I skip writing those both out? You'd get a minus 2x and then a minus 15 for the constant. Everybody okay? If you FOILed here, you'd get a plus 3x and a minus 5x, which would add together to be -2. Okay, so I want you to look up here at these, not at the factors, but at these, and tell me the relationship to that number. You multiplied them together and you got this one, right? That's the product. Whoops, that's a D. Sometimes I know how to write letters, sometimes not so much. Okay, that is the product of those. If I add those together, what do I get? If I add these, I get a sum of 2. And this is the opposite of that sum. Okay, I don't know why I have both the negative and the word opposite, just to make it confusing. All right, so one more time. If I had zeros of, somebody pick 2 numbers. 6 and 11, -11, you want positive or negative? Okay, 6 and 11. What is the sum of those 2 numbers? The sum would be 17 and the product would be 66. So if we write these as factors, x minus 6 and x minus 11, does it become, I'm using the shortcut now, x squared minus the sum with an x plus the product. So is this the same as this? Okay? Because I want to do that one more time with some lovely numbers like this. What is the sum of those? 0, yes? What is the product of those? negative 16i squared, which should be positive 16 after you change that to a negative 1. So I could write it x minus 4i and x minus negative 4i, which would be plus, and it would FOIL together to be x squared minus the sum x plus the product. Is that true? Now, we have to be very clear on something. Does x squared plus 16 factor? Only if we factored it with i's, right? It does not factor. Some of you on the quiz, you got down to that answer and then you decided it factored x plus 4 and x minus 4. But at the beginning of this problem, I said the zeros were imaginary, right? Okay. Okay, before we get to the really hard ones in a minute, I'm going to do one more. I don't know why I didn't just get a new page, sorry. Wasn't a good use of our time. All right, what if I had a 0 of 1 minus the square root of 3? What would the conjugate of that be? 1 plus the square root of 3. Now, if I had to write that in factored form, it would be x minus 1 minus the square root of 3 and x minus 1 plus the square root of 3. Is that lovely? You want to multiply all that together? Doesn't look very fun. Okay, can you go back up here, though, and tell me what the sum of those would be? 1 minus square root of 3 plus 1 plus the square root of 3. Everybody good that the square root of 3's, when you added them together, would go away when we get a 2? Okay, the product is a little more work. But if I multiply that times this, I get 1. In here and here, because they're opposites, they're going to disappear, right? Positive 1 square root of 3 minus 1 square root of 3. And at the back, what is the product of negative square root of 3 times positive square root of 3? Everybody good? So the product turned out to be? Yes? Okay, because this was the FOIL step here. I made that look like it wasn't a product. When we FOILed it together, it was 1 minus the square root of 3 plus the square root of 3 minus 3, which became this. That was when we FOILed it together, so it's the product. So now, using that rule, all of that disaster should FOIL together, or distribute together, multiply together, to become x squared minus the sum, which is plus the product, which is, okay. Does that factor? Okay, how would, if I told you you had to solve that, what would you have to do? Okay, help me do quadratic real fast. Opposite of b would be plus or minus the square root of, what's negative 2 squared? Minus 4 times 1 times negative 2. Well, 4 times 1 times negative 2 is 8, but the minus is going to become, minus and negative will be plus positive. So I'd have 2 plus or minus 4 plus 8 is 12 all over 2, which would be 2 plus or minus 12 is 2 square roots of 3 all over 2. Well, 2 and 2, I can divide everything by 2. Is that what we started with at the beginning of this problem? Okay. So have I proven to you that it works? All right, now we're going to go back and talk about rational zeros. Were those rational, the ones I just did? 1 plus the square root of 3 and 1 minus the square root of 3? No. Okay, rational zeros are nice. They can be written as a fraction, a terminating decimal, or some kind of integer. Now, the list of all possible rational zeros from any polynomial, comes from taking all the factors of the constant, which they call p, and all the factors of the leading Leading coefficient, which they call Q. All right, so if I had 2x squared plus 7x minus 9, where's the constant? The negative 9. And what are all the things that would divide evenly into negative 9? Plus or minus 1, 3, and 9, right? Plus or minus on each. And the leading coefficient is 2. And the only things that divide evenly into 2 are 1 and 2. And then you're going to have to write this out as a list, okay? 1, 3, and 9 all go over 1. Well, that wasn't too complicated. But then you have to go back and put them all over 2. So 1 over 2, yikes. 3 over 2, and 9 over 2. They're all positive or negative, but I won't make you write it on each one. Is that okay? You should have done that last year in Algebra 2, at least honors if you had it. Generated that list, okay? You have an example on your sheet. This one has a very nice leading coefficient of 1, right? And back here, negative 6. So all the factors of 6 are just 1, 2, 3, and 6. You put them over the factors of 1, and you just get 1, 2, 3, or 6, positive or negative. Then they graphed. That's an important piece, guys. Because I don't know how to factor x cubed minus 5x squared minus 17x minus 8. And you're going to be asked to find all the zeros. So they graphed it, and they found out negative 2 was a 0. So they put it in the little box as the 0, not the opposite. Brought down, multiply, add, multiply, got 14, added negative 3, multiplied 6. The remainder should be 0. If you graphed it and it worked, the remainder should be 0. Now, this is what is left. Everybody good that that's the depressed polynomial? This is the remainder. This is a constant. This guy gets an x, and this gets an x squared. Now, x squared minus 7x minus 3, does that factor? No, right? So how are we going to solve to find the other two zeros? Quadratic formula. Are you awake out there? Because I see some bobbing of heads already. Do you need me to write the formula? Opposite of b plus or minus b squared minus 4ac all over 2a. By the way, that is also one of the standards that is very low in the grade book. A lot of you never retook quadratic, and it's too late now. But it's also going to hurt if you don't know it by now, right? So hopefully you're still working on that. Okay, a, b, and c are 1, opposite, or negative 7 and negative 3. Quadratic formula. Opposite of b would become 7 plus or minus. What is negative 7 squared, guys? 49. And then it's minus 4 times 1 times negative 3 all over 2 times 1, which will be 7 plus or minus. This will become positive 12, so you get 61, I believe. Anybody type it in and get that? 49 minus 4 times 1 times negative 3. Okay, it was 7 squared minus 4 times 1 times negative 3. This is a minus up here. Yep, my tablet's still not working right. 61? Okay. So, does that simplify any further? No. What are the zeros? For this original polynomial way up at the top here, x cubed minus 5x squared minus 17x minus 6. You now found all three exact zeros, which if you had graphed, you would have got crazy icky decimals for two of them. But you now found them. One was negative 2. The other two were plus the square root of 61 over 2 and minus the square root of 61 over 2. And you could write those with a plus or minus. You don't need to list all three, list it out as three separate ones. So this is why we have to know how to do synthetic division and long division, is because we can find, if we can get it down to a quadratic, then we can find even the icky zeros. Exactly. All right. So on this question, I don't know if you have this. Yes, no, maybe. Okay, we're just going to practice the P over Q thing So it says list all the possible rational zeros. So what are which factors go on top? Yes, the factors of 36 over the factors of the leading coefficient, which is 2. This is a horribly long list. What goes into 36? 1 and 36, 2 and 18, 3 and 12, right, goes into 36? 4 and 9, and then 6. That's a lovely long list. And to make matters even worse, it is all over the factors of the leading coefficient, which are 2 is the leading coefficient. Okay. Watch what happens when I put all of those over 1. I just get everybody good? But what happens when I go back and put those all over 2 down here? 1 over 2 also adds positive and negative 1/2 to our list. 2 over 2. That's 1, it's already on our list. 3 over 2, not on our list. 4 over 2, it's already on our list. 6 over 2, 9 over 2, 12 over 2 is 6, 18 over 2 is 9, 36 over 2 is 18. So did we hit them all? So there's a lot, yes, because they're all positive or negative. All right, this is a much shorter list. Can somebody help me with this one? Factors of what on the top? You got to memorize this, guys. Factors of the constant go on top. What are the factors of 21? And the factors of the leading coefficient go in the denominator. So can anybody put that into one big list? 1, 3, 7, and 21, if you put them all over 1, but then when you go back and put them over 3, you get what? 1/3. 3 over 3 is 1. We already got that one. 7/3. 21 over 3 is 7, and that's already on our list. Okay. Everybody good? Need help? Okay. So we're going to do this question. It's an easy one. You have it on your notes, but it is an easy one because the leading coefficient is 1 and the constant is 20. So it's factors of 20 over 1. What are the factors of 20? 1, 2, 4, 5, 10, and 20. I don't care what order you list them in. If you need to write 1, 20, 2, 10, 4, 5, I don't care, okay? Then it says determine if any are actually zeros. I don't know about you, but I do not want to have to try all of those numbers. So we graphed it. You can graph it real quick. I graphed it right here. Anybody want to take a guess which ones worked? It looks like -2, 2, and 5, but let's try to prove that. So pick one that you think works. Anybody graph it and find a 0 they were happy with? +2 you want to do? Okay, what goes across the top? The coefficients from here, so we'd have 1, -5, -4, and 20. Bring down the 1, multiply times 2, add to -5, multiply times 2, add, multiply. What if I don't get a 0? Then it's not a 0. And if the calculator showed it was a 0, then you did something wrong with your synthetic division. Okay, what does this depressed polynomial mean? This was the remainder. That's gone. Constant x, x squared. Does x squared minus 3x minus 10 factor? What are factors of -10 that make -3? And what did we start with? Okay, this is the factored form. It actually asked for all the zeros. So what are the actual zeros that worked? 2, -2, and 5 in any order. Okay. On the quiz, I'll probably give you one where you can't just graph it and find all three easily. But that one you could have found all three just from the graph. All right. Complex zeros, just as when you do the quadratic, just as quadratic functions can have real or imaginary solutions, polynomials can also have zeros that are complex. The fundamental theorem of algebra just tells you that whatever the degree is, okay, that's how many zeros it should have. Okay, they might be real, they might be real but irrational, and they might be non-real or complex imaginary zeros. But that tells you the total of the zeros. All right, the conjugate root theorem. Do you remember that at all? We talked about the other day. It was on the quiz. It was real easy on the quiz, though. It was like if 4i is a 0, then -4i is also a 0, right? Well, now we're getting a little more complex here. 2 plus 3i is a root, then so is 2 minus 3i. Everybody good? If 2 plus the square root of 6 is a 0, so is 2 minus the square root of 6. Okay? We're going to have to find I don't know if that's attached to that or not. We're going to have to find yeah, well, that's good news because we'll just get rid of this one altogether. We're going to have to find the quadratic that these are solutions of. You ready to try this? Okay, so it would be x minus, you know what, don't even write this down because I'm going to show you the shortcut again. And this one would be x minus, okay, but pay attention. If I distributed that negative, what does this become? Minus 3i, everybody good? There was actually another parenthesis here. So if I distribute the negative so that I only have one parenthesis, it becomes minus 2 plus 3i. Okay, this is how you can do it on the quiz. This is the way everybody can do it. If you don't like the shortcut, please watch carefully. I'm going to distribute the x to everything back here. So x times x is x squared. X times -2 is -2x. X times positive 3i is plus 3i. Then I'm going to come back and I'm going to distribute the -2 to all of those. So -2 times x. Yeah, I missed an x there, didn't I? Thank you. Thank you. Okay. -2 times x. -2 times -2 back here would be plus 4. And -2 times that 3i back there would be minus 6i. Everybody good? Okay, now I got to go back and I'll change colors just for, I'm going to do -3 times all those. So I have -3i, times x. -3i times -2. And then -3i times positive 3i, which would be -9i squared. Doesn't matter how you wrote them. You could write them all in one long line. Okay? But what happens at some point is those two go away. These two go away. What does minus 9i squared become? So what do I have left? I have an x squared minus 4x. 9 and 4 is plus 13, right? Okay, how does that relate? Well, what is the shortcut again? If I go back to the top, what do we do with these to find the shortcut? The sum and, okay, what is the sum? 2 plus 3i plus 2 minus 3i. Okay, The product is a little bit trickier, but 2 times 2 is plus 6i, and minus 6i will cancel each other out. I'll be left with a minus 9i squared. What is 4 minus 9i squared? 4 plus 9, which is 13. So then the rule is it's the opposite here and the product here, the opposite of the sum and the product. Is the shortcut easier? You can do this. You can FOIL them all out if you want, okay? All right. Fundamental theorem of algebra. You have this on your notes. It says, if the degree is n, that's how many zeros there are, including repeated zeros. The conjugate root theorem, okay, says if a plus bi is a 0, so is a minus bi. So this is an easy example. It says write a polynomial function of least degree with real coefficients in standard form that has a 0 at 0. So what is a factor if this is a 0? Just x minus 0 or x, guys, yes? Okay, if I have square root of 2i, I would have x minus the square root of 2 times I. That's really gross. And what else would have to be a 0? If square root of 2i is a 0, negative square root of 2i would also have to be a 0. They have to come in conjugate pairs. Are you getting that? And if it was x minus that, it would become plus square root of 2i. Okay, it wants this in standard form. Well, you want to FOIL those two together? It's not really that bad on this one, right? X times x is x squared. What's going to happen to this term and this term? They're going to cancel because the signs are different. Then I have minus a square root of 2 times a square root of 2, which is 2, and I times I, which is I squared. X squared minus 2i squared becomes minus 2 times a negative 1 would become plus 2. This is where I would let you stop. The book says standard form. If you did this and we're looking for your answer in the back, you'd have to go all the way to here. It doesn't matter to me. You just have to have real numbers at the end. Okay. Anytime you have a 0, the opposite of that is what the factor is. All right. Find all complex zeros of this, given that 2 plus I is a 0. You have this on your notes. First of all, what would all the possible rational zeros be, guys? All the factors of what? 30 over 1, right? Okay, just reviewing that. Okay, this one, though, says we've been gifted with this lovely information that 2 plus I is a 0. So what is also a 0 is 2 minus I. Now, do you want to do this all out once together? Or you want to use the shortcut? Okay, if we distributed all those negatives, we'd have x minus 2 minus I times x minus 2 plus I. And we'd have to FOIL it together. If we want to use the shortcut, we're going to take those two zeros, 2 plus I, and we're going to add them. What is the sum of those two zeros? I'm not FOILing, I'm just adding. So the sum is 4. The product, now if I do FOIL them together, that's a big times right there. I get 4 minus I squared, yes? Because the plus 2I and minus 2I. And what is 4 minus I squared become? 5, because it's 4 minus negative 1, or 5. So if I FOILed all that together, and I can do it real fast for you, x squared minus 2x plus ix minus 2x plus 4 minus 2I minus ix plus 2I minus I squared, okay? These would cancel out, these would cancel out. I'd have an x squared. Minus 2x and minus 2x is minus 4x. And 4 minus I squared is positive 5. Is that what we got over here? Opposite of the sum and the product? Okay. So you don't have to do it this way. All right, but it says find the other two zeros. This was a degree 4 polynomial up here, yes? So there's 2 more zeros. Lovely. We could graph, but the other thing we could do real fast is x squared minus 4x plus 5 into the original polynomial. Can you guys... Okay, the original polynomial was x to the... great, tablet's gonna give me trouble all of a sudden. X to the 4th minus 5x cubed plus 3x squared plus 19 at home. Okay. Long division. X squared becomes x to the 4th within x squared. So I get x to the 4th minus 4x cubed plus 5x squared. Changing colors, subtract. This becomes add, subtract. Okay, then I have a negative 1x cubed and a negative 2x squared. And I could bring down a 19x. Did I do that right? Okay, now what? To get a negative x cubed here, I would need to multiply back here by a negative 1x. I'm sorry, my tablet is... That'll be a negative 1x cubed plus 4x squared minus 5x. I'll try to write that a little better. Okay, when I go through and change signs and add, this is now a negative 6x squared plus 24x, and there's a minus 30 up top I can bring down there. Okay, x squared to become this would need to multiply by exactly what? Negative 6, so that gives me negative 6x squared plus 24x minus 30 when I distribute. And if I change all those and add, I get nothing. Okay, so where are the other two zeros at? This had disgusting zeros of 2 plus I and 2 minus I. But this is our leftovers, and that has nice zeros because it factors x minus 3 and x plus 2. So 3 and negative 2 are the two nice zeros. So right up here, the other two zeros were 3 and negative 2. Would it have been a whole bunch faster to factor and find those two real ones? Okay. Anybody need more time? Actually, the other direction would be on your quiz, where you had to graph and then find the two real and divide them out, and then maybe at the end find imaginary or complex. All right. This is a quick example again. Write a polynomial function of least degree with real coefficients in standard form that has the zeros. Negative 4, 1, 4 plus I. What do you know has to also be a zero then, guys? 4 minus I. Everybody good? You only change the sign in the middle. Conjugates. Been doing this since the beginning of the year. Okay. Now, I need to write those as factors. So -4 becomes x plus 4, 1 becomes x minus 1. Now, what do you want to do with those? Do you want to write them as x minus the quantity 4 plus I, and then x minus the quantity 4 minus I, and go ahead and FOIL it all together after you distribute the negatives? Or do you want to use the shortcut? Okay, the shortcut is we need to find the sum and product of these two zeros. If I add 4 plus I to 4 minus I, what do I get? Okay, if I multiply them together, I get 16 minus an I squared. 4 times 4 is 16, the middle terms drop out, and a negative I squared. What is 16 minus I squared? Okay, then how does that go? It's x squared, the opposite of the sum, which would be x, plus the product, which would be does anybody want me to see me do it again out, all the way out? Huh? Anybody think they would do it by multiplying x minus 4 minus I times x minus 4 plus I? Do you understand what I'm doing when I'm doing all that? That I'm just distributing the x to all three of those things, and then the -4 to all three of those things, and then the negative I to all the... All right. I am fine with you writing it like this. This question in the book, they will FOIL that all out and get an x to the 4th, blah, 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 blah. I don't want you to mess with that. If you can get it to that, I'm great, okay? So don't check the answers in the back of the book. Check the key that's on the Google Classroom for those. All right, we are moving on. It says there are two ways you can write these, guys. This, what we wrote right here in this blue box, is called irreducible factors. None of those factor any further, true? But while this, please pay attention, while this is a linear factor right here, this one is a linear factor, this one is not linear. Do you understand that? That's quadratic. If you had to write it as linear factors, this is what you would have had to write. Okay? Those are the linear factors. Look. Okay. So for this question right here, this is number 4 in your notes, and I really want to get through this. What you would do first is graph it. Okay? I graphed it. Here's what it looked like. Can you tell anything right there from that? What does it have as a 0? Right down there it says -6, yes? So how would you start dividing? Into 1, 2, -15, 18, and -2, 16. Bring down, multiply, add, multiply, add, multiply, add. Somebody help me. Did I do that right? Anybody check in my... Okay. The next one, this is still degree what now, guys? This is a constant. This is an x, x squared, x cubed. Still icky, right? So we use that depressed polynomial, and another 0 we can find on the quiz, on the calculator, I mean. It has one at 4 as well. So we keep going. Put a 4 here. Bring down, multiply, add, multiply, add, multiply, add. Okay, does this graph show 4 zeros? No, it only shows 2 real ones, so there must be 2 imaginary ones because it was a degree 4. Well, for part A, it says, write the linear and irreducible factors. That would be x plus 6, x minus 4, and what's this depressed polynomial right here? X squared plus 9. Everybody good? Okay. If I set that one equal to 0, x squared plus 9 equals 0, I get x squared equals negative 9. What is the square root of negative 9? 3i. So the actual zeros are negative 6, 4, positive 3i, and negative 3i. The other thing it asks for are the linear factors. So you would have to go x plus 6, x minus 4, and what are the other two if this has to be in, yes, any order of 3i and minus 3i, okay? These are linear, and these were what's called irreducible. All right, we did not get to number 5. That will be our warm-up tomorrow. This is the assignment you need to be working on. It's on the homework check sheet in the back.